Assalamu alaikum warahmatullahi wabarakatuh.
All right, so let's get into it. It is Wednesday, February 18th, 2026. If you're listening to this in, say, Saudi Arabia or the UAE, well, the
Right.
coffee has been put away. For millions of people, today is the first day of Ramadan.
It's a huge moment.
Yeah.
That whole shift in rhythm, the focus, it's the start of the most important month in the Islamic calendar.
But, and this is really why we're doing this deep dive, if you're listening from Oman or Morocco, or maybe you work at the UK's Nautical Almanac office, today is, well, it's just Wednesday.
Right. For them, it's still Shaban,
Yeah.
no fasting yet.
We have a split, and these splits happen, but usually it's about geography, right? This one feels different. I was digging through the sources. We have technical papers on Crescent visibility, data from the International Astronomical Center, some really fascinating stuff on neurobiology.
And it's not just a disagreement, it's a collision.
A collision of what?
Of two different definitions of reality, really. On one side, you have this legal reality that says witnesses saw the moon last night, on Tuesday the 17th. But then you have the scientific reality, which says, look, according to every law of orbital mechanics we have, seeing that moon yesterday was physically impossible.
And we're not using impossible loosely here, are we? This isn't like, oh, it was a bit cloudy.
No. We're talking about a moon that, in some places, had already set below the horizon.
Before the sun did.
You can't see what isn't there.
You can't, and yet the announcement was made.
So that's our mission today. We're not here to debate theology. We're here to look at the source material, to try and understand how a geometrically invisible moon was seen by enough people to start a holy month. It's part detective story, part astrophysics.
And part a crash course in how the human brain works. I love this stuff because it exposes that tension between what we calculate and what we experience.
Okay, so let's set the scene. Take us back to yesterday evening, Tuesday, February 17th. Sun's going down over the Arabian Peninsula. What's the feeling on the ground? It's tense. You know, the lunar month officially begins the moment the new crescent, the halal, is sighted with the naked eye. So you've got committees from the Supreme Court in Saudi Arabia, committees in the UAE, Qatar, Kuwait. Everyone is out, scanning that western horizon.
The pressure must be immense. You have literally millions of people just waiting for the signal.
Massive. And usually, the process is very strict. But last night, witnesses came forward. They testified. They swore they saw the tiny curve of the new moon.
And the courts accepted it.
They vetted them, accepted the testimony, and made the declaration. Boom. Ramadan starts February 18th.
But then you look, just across the map. Oman, Morocco, scientific bodies in the UK. They looked at the exact same sky data and said, what?
They essentially said, no, we don't buy it. They rejected the reports completely and declared Ramadan starts tomorrow, Thursday the 19th.
So let's get into the why. Because I look at the data you sent over, and it's pretty damning. But
Yeah.
Let's play devil's advocate for a second. The people who reported this, they're not lying, are they? These are serious, pious observers.
Absolutely not. They are not lying. And that's what makes this so fascinating. We have to separate honesty from accuracy. You can be 100% honest and still be 100% wrong about what you saw.
Okay.
But before we get into the psychology of why they saw it, we have to establish why astronomers are so certain it wasn't there to be seen.
Right. So let's get into the physics. The report gives this sighting a P5 rating. What on earth does that mean?
It's a code. In Crescent visibility research, code A is easily visible. The code C means you need a telescope. P5 is the code for invisible. It basically means the parameters are outside the known bounds of physics.
And the first reason for that is something called the conjunction.
Right. Conjunction is the exact moment of the new moon's birth. It's when the moon passes directly between us and the sun. And that happened at 12:01 UTC on February 17th.
And we know that for a fact because, and I can't believe I missed this in the news yesterday, there was a solar eclipse.
Yes. An angular solar eclipse over Antarctica. That is the ultimate receipt. We have proof the moon was dead center in front of the sun at that exact time. It's like a timestamp.
Okay, so 12:01 UTC. Now, fast forward to sunset in, say, Riyadh. That's around 5:30 p.m. local time. So that's only, 4 or 5 hours later?
Correct.
Yeah.
So at sunset, the moon is only about 4 hours old.
Is that young?
It's an infant. I mean, it's basically fetal. To give you some context, the world record for sighting a moon,
The youngest ever seen.
the youngest ever seen. And this is with powerful telescopes, high-altitude, computer-guided systems. That record is for a moon that is roughly 15 to 18 hours old.
Whoa. Wait, so the world record with a telescope is 15 hours old,
Huh.
and people claim to see a 4-hour-old moon with their naked eyes.
Exactly.
Yeah.
We are talking about something 3 or 4 times younger than the absolute limit of our best technology, let alone the human eye. It just hasn't moved far enough from the sun to reflect any light back to us yet.
This connects to that term in the charts, elongation.
Elongation is just the angle in the sky separating the moon and the sun. If it's too close, the sun's glare just wipes it out. Yesterday, that separation was only about 1 to 2 degrees.
And this is where that Dan-John limit thing comes in. I fell down a total rabbit hole reading about this. It sounds like something from science fiction, but it's really about mountains.
It is. It's named after the French astronomer André Danjon. He realized something critical. The moon isn't a smooth, polished ball. It's a rock. It has topography, mountains, valleys, craters.
Which means it casts shadows.
Precisely. And if the moon is very, very close to the sun, and the magic number is 7 degrees, the sunlight is hitting it at an incredibly shallow angle. It's just grazing the surface.
Like holding a flashlight right against the floor.
Perfect analogy. And because of those lunar mountains, that shallow light creates these really long shadows. Danjon figured out that below 7 degrees of separation, the shadows cast by the mountains actually stretch all the way across the valleys. They connect.
So the shadows basically swallow the light.
They literally break the circuit. There is no continuous illuminated rim to see. It's not that the crescent is faint. It's that the geometric shape of a crescent doesn't exist yet. The shadows are blocking it.
That's amazing. So at 1 or 2 degrees where we were yesterday, we're way, way below that limit.
We are deep in the dark zone. Physically, the light is not getting off the moon towards Earth in a way that forms a curve.
But there's an even simpler problem in the data, isn't there? The timing, the lag.
The moonset lag. And for me, this is the most damning piece of evidence. It's the time difference between sunset and moonset.
Right, you want the sun to go down, the sky to darken a bit, and then for the moon to hang around for a while so you can spot it.
You need it to linger. But in Riyadh yesterday, the lag was, well, it was negative.
Negative.
The moon set before the sun. About 0.6 minutes before, to be specific. In Abu Dhabi, it was about a minute before.
So, hold on. Let's be really clear about this. People were standing on the ground, looking west, and claiming to see a moon that had technically already disappeared below the curvature of the Earth.
In many key locations, yes. Or at the very least, it was setting at the exact same moment as the sun.
Which means you're trying to find a tiny, unlit sliver of rock while staring directly into the blinding glare of the setting sun.
It's impossible. You just cannot see the moon if it has already set.
One of the sources had a great analogy. They said it's like claiming to see the first light of sunrise when the Earth is only rotated halfway through the night.
Or seeing a rainbow before it rains.
Yeah.
It's a timing error. The moon moves about half a degree across the sky per hour. You need 12 to 15 hours of movement to get a visible crescent. Claiming to see it at 4 hours is, well, you're skipping the basic mechanics of the solar system.
Okay, so geometry says impossible. Dan-John limit says no light. Moonset lag says it's below the horizon. But I'm going to push one last time. Let's just say, for the sake of argument, there was one tiny speck of light, a weird reflection off a mountain peak. Could a person with superhuman vision pick it out?
Even if we ignore all the physics and pretend there was light, still no. And that brings us to the atmosphere.
The candle at noon idea?
Exactly. Even if there was a sliver, and remember, illumination was calculated at less than 0.1%, you're not looking through a vacuum. You're looking through the thickest, dirtiest, haziest part of our atmosphere.
We've all seen this. The sun turns red at sunset because you're looking through all that dust and humidity right at the horizon.
That's what we call atmospheric extinction. When you look straight up, you're looking through one air mass. When you look at the horizon, you're looking through 20, maybe 30 air masses, like a heavy filter.
It just eats the light.
It destroys the contrast. And contrast is everything for the human eye. We don't really see objects. We see the difference between an object and its background.
And the background, in this case, is the bright twilight sky.
Which is still incredibly bright. So the analogy from the source material is perfect. Imagine trying to spot the flame of a single birthday candle.
From miles away.
From 10 miles away, while you are staring directly into the beam of a lighthouse.
The signal is just buried in the noise.
Completely. The signal-to-noise ratio is effectively 0. The background sky is literally brighter than the moon itself.
I liked the ink analogy, too. It said trying to see the moon yesterday was like trying to read a sentence before the printer has actually put the ink on the page.
That's it. The moon just hadn't moved far enough to print the crescent on the sky. The page was blank.
So this is the real pivot point of the deep dive. We have established pretty comprehensively that the moon was not there. Physically, geometrically, optically, not there. And yet, people saw it. Not one person, several. How?
This is where we leave the world of astronomy and we enter the really fascinating world of neurobiology. We have to talk about pattern completion.
The brain filling in the blanks?
It's more than that. It's an evolutionary survival mechanism, you know? Think about it. You're a hunter-gatherer. You see a flash of orange in the tall grass. You don't see the whole tiger. You just see a patch of color.
But you don't wait around to check. Your brain just screams, "Tiger!" and you run.
Exactly. Your brain takes a tiny fragment of noisy data and it completes the pattern based on what it expects to find. It fills in the rest of the picture for you. Now apply that to the moon sighting.
You've got a witness out in the desert. The expectation is sky high. Millions of people are waiting, praying for the month to start. They want to see that moon.
Desire is a powerful filter. So you're staring at a bright, hazy, complicated horizon. You've got dust, heat haze, light scattering everywhere. It's a very noisy visual field.
And your brain is scanning all that noise for one very specific shape, a tiny, faint curve.
So when you see a wisp of a cloud that's slightly curved, or trick the light from the heat wave,
Your brain just goes, that's it, that's the curve.
it helps you out. It paints the rest of the picture for you. And in that moment, you are no longer seeing a cloud, you are seeing the Holy Crescent. And the witness believes it, 100%. To them, it's completely real.
The sources mentioned a few specific imposters, too, things that can get mistaken for the moon.
Oh, the sky is full of them. Mercury is a classic one. It's always near the sun, and to the naked eye, it can look like a bright smear of light. If you're looking for a moon, Mercury can easily become one.
What about jet contrails?
A huge one in the modern era. You know, a distant plains trail 50 miles away, catching the last rays of the sunset. If the wind curves it just right, it looks exactly like a glowing white arc.
And what about binoculars? I saw something in the report that said using them can actually make things worse, which seems totally backwards.
It does, doesn't it? But if you point binoculars anywhere near the sun, you get internal reflections. Light bounces around inside the glass elements, and these reflections often appear as little curved flares or ghosts.
So you see a crescent, but it's just a ghost in the machine of your own equipment.
We call them false positives. And if you don't know what an optical flare looks like, you will swear on oath you saw the moon.
There was a really good analogy in the sources about the ship captain. I think it frames this whole conflict perfectly.
It really does. Imagine you're a ship captain. It's dusk. Your GPS says you were 200 miles from land. Your charts say you're in the deep ocean. But a crew member up in the crow's nest yells down, "Land ho! I saw it! Land on the horizon."
And the captain has a choice.
A big choice. Do you trust your instruments? The GPS, the math, the satellites? Or do you trust the human eyes of your crewmate?
And in this case, the captain, the Supreme Court, or the religious committee, they chose the human element.
It's a clash of systems. The scientific system prioritizes the calculated reality. It says the math says X, therefore X is true. But the traditional system prioritizes the legal reality of human testimony.
Meaning, if a trustworthy person swears they saw it, that testimony becomes the truth, legally.
Yes. The verification is about the witness's integrity. Is this an honest, known person? If so, their word has incredible weight. The system isn't really designed to ask, is this physically possible? It's designed to ask, is this person trustworthy?
Which leads to a collision because an honest person can still be wrong.
Exactly. There's a statistic in the notes on this that's kind of staggering. Studies comparing historical sightings to astronomical data show a false positive rate of roughly 20 to 30%.
Wait, really? 20 to 30%. So 1 out of every 3 or 4 times, people are reporting a moon that isn't physically there.
That's what the data suggests. It just goes to show how much our expectation shapes our perception. When we look for something hard enough, we tend to find it.
And that explains the split we have today. The Muslim world is basically divided based on which captain they decided to follow.
Perfect way to put it. Saudi Arabia, the UAE, Yemen, Iraq. They accepted the lookout's testimony. They started Ramadan today, February 18th.
And the others?
Countries like Oman, Morocco, Malaysia, Brunei, Indonesia, they stuck with the GPS. They looked at the charts, saw the moon set before the sun, and said, we can't accept a sighting that defies physics. So for them, Ramadan starts tomorrow, the 19th.
It's interesting how the process works, too. The committees meet right after sunset, but the announcement can take hours.
It does. I mean, the vetting is serious. They bring the witnesses in, they interview them, ask them about the Crescent's position, its orientation.
But even after all that, they accepted the testimony, despite the astronomers rating it P5, or impossible.
Because in that specific legal framework, the astronomical calculation is a guide, not a veto. If the human testimony is deemed strong enough, it can override the calculator.
What a fascinating situation. A geometric impossibility has become a social reality.
That's a great way to say it. The moon wasn't physically there, but for millions of people, the month has begun anyway. The reality of the calendar has sort of detached from the reality of the orbit.
And it makes you think about how we all process information. We like to believe we're data-driven, but we're constantly balancing that hard data against our own experiences, our community.
We want to believe our eyes. And sometimes that conflicts with the cold, hard math. It's a good reminder that truth can be defined in different ways.
Right. Is the truth what the computer model says? Or is it what a community agrees upon and acts on?
In a legal or religious context, truth is often defined by the procedure. If the procedure was followed correctly, the result is considered valid, even if the satellite data disagrees. They're just two different languages describing the world.
Before we go, there's one last thought I want to leave everyone with. Something to look for tonight.
Yes. The smoking gun, so to speak.
Tonight, that's the evening of February 18th. Wherever you are, just go outside after sunset and look to the west.
Tonight, the moon will be about 40 hours old. It'll be high, it'll be bright, and it'll be very, very easy to see.
And because it's that old, it's going to look pretty big for a first-day moon, right?
Exactly. A true first-day moon is a razor-thin, almost ghostly wisp. You really have to squint. But tonight, people are going to look up and see this thick, bright, robust crescent.
And a lot of them are probably going to think to themselves,
wow.
yeah, that looks way too big to be the first night.
And they'll be unknowingly confirming that the calendar might just be one day off. The moon will essentially be shouting down, hey, I've been here for 2 days.
Or maybe just confirming that the moon keeps its own schedule, regardless of what we decide down here.
It certainly does. It's the ultimate celestial clock. It doesn't wait for any committee.
A clear sky, a big moon, and a bit of a mystery. Whether you started today or you're starting tomorrow, it is a fascinating time to look up. Thanks for taking this deep dive with us.
Always a pleasure.
See you next time.